We've been having lots of fun with monohybrid and dihybrid and simple Punnett squares, but now we got to mix it up with genetics and X-linked genes. And so sometimes we have genes that are carried on the X chromosome but not on the Y. And that can cause a lot of crazy things, especially for those poor boys who only get one X and it's all their mother's fault. So let's take a look at some X-linked genes and how to work these particular problems. So in fruit flies, eye color is a sex-linked trait. Red is dominant to white. So that means when we see the capital R, we're looking at red, and the little r, we are looking at white. Now you'll notice when they wrote these, they put it as a superscript. So they have X to the big R and X to the little r. And so what this means is that it is a sex-linked trait carried on the X chromosome. And so you can kind of look at it in isolation as to just the R's. If you were to cover up your X's, you'd see we have big R, little r. And so if we have two X's, that means we have a female. And if it's big, little, since red is dominant to white, that means she has red eyes. This one right here is big R on an XX, so XX means we have female, and big means that her eyes are red. Now over here, we have X and Y. So when you see X and Y, that means we are male, and he can't inherit two R genes, so he only expresses the one that he has, which is the big R, and so that means he has red eyes. Here we have XY again, and so that is another male. And he's got the little gene, so that means his eyes are white. And then finally over here, our last one is XX, which means we have a female, and since they're little, that means her eyes are also going to be white. So we come down here, what are the genotypes of these flies? If it is a male, we know right away that we are going to have XY, and if he has white eyes, that means that on his X chromosome he's carrying the white gene. And so remember, big R is red, little r white, so that means he is X with a little r and the Y. If we have a white-eyed female, her genotype is going to be XX. The only way to have white eyes is if both X's are carrying the recessive allele, which is the little r. So we're going to do little r, little r. If we have a red-eyed female, and they've done a nice thing and told us she's heterozygous, so she's going to be XX, and if she's heterozygous, that means one X has the big R, and the other X has the little r. And then a red-eyed male, if he's got to be XY because he's a boy, and then he's red-eyed, so that means this X is carrying the capital R. So then we get real interesting when we show the cross of a white-eyed female with a red-eyed male. So when we draw our Punnett square here, it is just a monohybrid sex-linked cross. We're just going to look at the X's and the Y's. You draw your square out. We usually put the male at the top, so he can donate to his offspring his X with the red gene, or they might be boys and get dad's Y. Mom has X with the little r's on both of hers, so she's homozygous recessive on her X's. We usually do moms down the side, so you'd have X little r and X little r. When we draw these out then, complete it, this one would get X big R, X little r. Now you could reverse that and do the little r first and the big R second, but general English rules we usually do the capital R first. Down here we do X big R, X little r, and then XY inheriting the little r, and XY again inheriting this. Now that doesn't mean that this crossing is going to have two boys and two girls. It just means they got a 50-50 chance of being male or female, and that our females would have a 100% chance of having the red eyes, and our males would be 100% white eyes. So when we go on to question 4, we're going to show a cross between a pure red-eyed female and a white-eyed male, and what are the genotypes of the parents. So a pure red-eyed female, when we're talking about a pure, that means that both her X's are carrying the red-eyed gene. So we would do her X big R, and our white-eyed male would be X little r with the Y. And so you're going to draw out this Punnett like you did the one before. We usually do dad on top, and we do mom down the side. It's a male-dominated society, so I guess you could put the guy on top of the box. And you would work this out. And so you would do X big R, X little r, X big R, Y, X big R, X little r, and X big R, Y. And you can count out how many are of each. So our white-eyed male, well, how many of these males would be carrying that white gene? 0. White-eyed female, that means they have to be little r, again, 0. How many red-eyed male are on this particular one? Well, big R, there's 2, and red-eyed female are also 2. Now, I don't like really doing this, how many are there. I would usually want to know like what percent or what ratio. So if we were to change this to percent, these would obviously be 0%. And over here, of our males, how many of our males would be red-eyed? Well, if we look here, both of them would be. So that means that we would really have 100% being red-eyed males. Of our females, how many of those would be red eyes? Again, we would have 100%. So really not worded the best way here. We would want to look at that more in terms of percent. And so you guys are going to go ahead and do the rest of this one. I'm going to let you work it on your own. And then also do the second half of that worksheet over here on your own as well. This one is kind of interesting because it talks about hemophilia. And gives you a little bit more terminology. When we see a female as a heterozygous, we usually refer to her as a carrier for that particular gene because she has it, but she doesn't show it. And so it's kind of an unfortunate thing. She doesn't know that she is carrying that sickness, and there's really a 50-50 chance of her sons getting it and a 50-50 chance of her daughters inheriting that gene and either having the disease or being a carrier themselves. And so when you start working these, it's kind of a neat thing to look at. I've got the key at the front, so as you go through it, let me know if you get stuck, and you're welcome to come on up and check your answers. Thanks.